Okay, we're on to linear regression, and we're still dealing with the concussion, the spit test, the microRNAs that are found in people's saliva. And so this is some kind of measurement. It shows like how many are in there, and then the length of symptoms in days. So we've got a bunch of data collected here, and we could look at this and basically say, oh, okay, well, you know, it's I don't know, moderate, positive association, I guess linear, you know, but because it kind of fits this line of best fit, but we've got some deviation here. So in addition to the scatter plot, we like to look at this residual plot and see that is the data spread out nicely across all x values, or is there some kind of systematic deviation or pattern going on here? And I would argue that there is this pattern going on here, and you can really see it in the residual plot, which is the observed values as compared to a predicted, and that's what this line is, the predicted, sorry my handwriting, but the predicted value. All right, and here I want to note just a couple of things. Length of symptoms in days. I'm going to put a hat over that just to indicate that's our y hat, equals, and then we've got times microRNAs, that's our x value, and then minus this 6.6. So what is this? Well, that's the slope. Okay, so we've got slope, y-intercept, we've got an r squared, but no r value. So this is the coefficient of determination. It tells you what percent of the changes in y can be explained by the changes in x, or 58% of the change in length of symptoms can be explained by the change in the microRNAs, not caused by necessarily, but explained by the changes in that. And then the r, if you want the r value, well, you got r squared, so you'd have to square root it to find the r value. And then just double check and make sure that when you do that, if you do that, that the slope is positive, because then you've got the right value. But if the slope were negative, then you would need to make that a negative correlation. All right, so let's take a look at some of the interpretation. What if you were given 5 pieces of information and asked to come up with the least squares regression line? So here's something we haven't seen in a little bit. We got x bar, so the average x meaning the symptoms length in days or whatever it was. The y bar, that was the microRNAs. Oh, the average microRNAs. Woo, I got this whole backwards. X bar was the microRNAs, so that's the average microRNAs found in the spit test. And then we've got the y hat, which is the average y values, and that's the length of the concussion. And then we've got the standard deviation of the x, the average amount that those RNA values varied, and then the average length of symptoms, how much it varies, and this correlation, which was just the square root of that r squared earlier. If you had those 5 pieces of information, could you come up with the least squares regression line? Well, yeah, of course you could. These formulas on the formula sheet that you get, B sub 1, I don't think I have the little sub 1 there anymore, but B is the slope, and it's just the correlation times the standard deviation of y over the standard deviation of x. And that kind of makes sense. The change in y's, the variation in y, over the change in x. That's rise over run, isn't it? And then we just multiply it times this correlation to give it like a strength to it, and then you get that slope. Once you get the slope, then you can set it equal to, well, this is just, once you get the slope, then you can go back into this formula, which is the average y is equal to the slope times the average x, which highlights the fact that the average x and y are going to be on the least squares regression line, plus the y-intercept. So to get the y-intercept, you fill in everything you know. All right, you fill in that because you were given that information. You were given this, and you calculated the slope. So you basically plug that in, solve for your y-intercept, use your little bit of algebra, and then finally come back and put it together to make your least squares regression line. All right, in our next little segment, we're going to talk through some of the details on slope, y-intercept correlation, and so forth, and interpreting that residual plot. So come back.